Today we are going to learn about LED blinking with Arduino. We are going to use this Arduino Uno with our LED blinking. We are going to blink 2-pin LEDs, simple LED. This one is our LED. This has two terminals. If we zoom it, this has two terminals. This one is positive terminal and this one is negative terminal. This positive terminal, if we apply some voltage, anyhow we can apply some voltage between these two pins. Let's have a look. When LED is connected with battery, our LED is on, and when it is disconnected, LED is off. Now let's control one LED with Arduino Uno. What do we need to make this happen? We need one Arduino Uno and resistor and one LED. So we are going to make the circuit. D0 pin of our Arduino Uno is connected with resistor's first pin. Second pin of resistor is connected with positive pin of LED, and negative pin of LED is connected with the ground of Arduino. So this is our overall circuit, and this circuit is complete. Before moving to coding part, let's understand hardware and circuit a little bit more. This is Arduino Uno, which comes with Atmega 328 microcontroller. It has 14 digital pins and 6 analog pins. Any pin can be configured as an input or output. Output pin means we can program output pin to become high or low logic. Whenever any pin is made high, it supplies voltage outwards shift. Means we can turn on anything like motors, relays and LEDs. But there is something we need to remember, and that is a driver. If we are connecting devices which has high current requirement, we will have to put a driver in between them. We will talk about it in later chapters. For now, we are only experimenting with simple LEDs and that do not require any driver if we are driving at most 10 LEDs from our Arduino. So what is input? If any pin is programmed to become input, we can further program our Arduino to detect high or low logic coming to that pin. And with this facility, we can make switches, touch keypad and sensors work. Now, if we look at the circuit again, it is clear. For blinking the LED, we need to make D0 pin as output. We are placing a resistor in series with LED. Why are we placing a resistor? Let's understand this. LED has a characteristic called forward voltage. In short, we call it VF. VF is the amount of voltage lost in LED when connected to power supply. Forward voltage for red LED is 2 volt. That is why we cannot connect our LED directly to 5 volt. We need to put a resistor in series to down the voltage reaching at LED. When D0 pin is made high, voltage at D0 pin will be 5 volt. So how do we calculate the resistor value? For a standard 5 mm diameter LED, maximum current is usually 20 mA. So 10 mA or 15 mA are suitable values. So now let's calculate resistor value at 10 mA. By Ohm's law, we know voltage is equal to current multiplied by resistance. In short, we call it V is equal to IR. So if voltage is 3 volt across the resistance and current is 10 mA, then resistor value will be 300 ohms. So we are choosing the nearby value available as 330 ohm. If we increase the resistor value, less current will be drawn, and so the LED will be less bright. Now let's make the circuit on hardware. Let's take one Arduino Uno and we are making connections using breadboard. We need LED and resistor and some connecting wires. We are inserting this LED over here. Positive pin is on this side and negative pin on this side. We are inserting this resistor over here at positive side. And making the connections with connecting wire. Resistor's other pin is being connected to D0 pin of Arduino, and negative side of LED is connected with ground pin. Our circuit is complete. Let's code now. In your laptop, open your Arduino IDE. Every Arduino program has these two default functions, setup and loop. In setup function, we will write initialization part of our code. Like here, we need to make pin 0 as output. So we will write pin mode 0, output. Now our pin 0 is set as output, which can either become low, means 0 volt, or high, means 5 volt. So for making our LED off by default, we are writing digital write 0, low. In loop part, here comes our main flow of logic. So if we want to blink our LED repeatedly, we have to write digital write 0, high. This function will make pin 0 as high, means 5 volt, and our LED will be on. And it will remain on for 500 millisecond. So we are putting a delay of 500 millisecond by writing this function delay 500. Now we are writing digital write 0, low. This will make pin 0 as low, means our LED will be off. Again, we are placing a delay of 500 millisecond using this function, and that's it. This loop function will be called again and again for infinite times till the power of Arduino will be on. Now let's program our Arduino. Connect your Arduino board using A to B type USB cable with your laptop or PC's USB port, and go to Tools menu in your Arduino IDE and select this COM port associated with your Arduino and press on upload button, and here we go. Our LED is now blinking with the delay of 500 millisecond. If we reduce the delay in our code to suppose 50 millisecond and upload the code again, now our LED is blinking much faster with a delay of 50 millisecond. And again, if we increase the delay to suppose 2000 and upload the code again, now it is blinking very slowly. So this is the end of this session. In next session, we will learn how to use multiple LEDs.